solve the equation by calculator methods and then by hand with algebra. So here is our equation. Set equal to 0. It's a polynomial function. Here's the function. Set equal to 0, so we're going to find the zeros of the polynomial, which are also called the roots, which is also the same thing as the y-intercepts. So we put the function in y1, graph it on a descent window that shows the roots here, do a second calc 0 to find that root, which is negative 1.5, and do a second calc 0 again to find this root, which is x equals 5. Now, if you don't know that negative 1.5 is 3/2, the general way you convert it back to a fraction is on the home screen you put negative 1.5, then you do math number 1, which turns this into a fraction, and it puts the answer right there. So the two solutions to the original equation are the same thing as the roots of the polynomial, which are x equals negative 3/2 and x equals 5. The solution set in set notation is this. And let's check it by hand. By hand we have the original equation. We're going to factor the polynomial on the left, and so it's 2x and x. 15 requires a 5 and a 3, or 15 and 1. So when you do the different orders, you realize that this is negative 10x plus 3x matches up to negative 7. So this is the right order. And that's set equal to 0. So you have the zero factor principle, which says that if a product of two numbers is 0, then one is 0 or the other one's 0. So you set these equal to 0, subtract by 3 on both sides, divide by 2 on both sides, and you get this. And this, just add 5 to both sides, and you get that. So the solution set is exactly the same as it was previously. Now, just tying this into what we did before, it's interesting to note that from the roots you can get the factorization. From the factorization you get the roots. So here is the factorization of the polynomial. R are the roots. There's a 2 as a leading coefficient, so the a is a 2. So you put that in, you go x subtract negative 3/2 times x subtract 5. Those are the two roots. Then you clean that up to put a plus there. Then you distribute the 2 in on the one that will cancel out the fraction, and that's the first one in this case. So that's 2x plus 3 times x minus 5. That is the factorization, and of course then you can find the roots from there and go around in a circle. So this is really true. From the roots you get the factorization. From the factorization you get the roots.